Hi everybody, today I am going to explain you about the hyperspectral images. So generally the hyperspectral images, it allows you to have the processing that is done on the different wavelengths. So generally you will be having the different kinds of your images like multispectral images, hyperspectral images and ultraspectral images are the one. So multispectral images are the one that acquires the information only on about 10 bands. Okay, that is within 10 bands it will acquire the information, and this hyperspectral images, it gives you the spectral information on hundreds of narrow bands. So automatically it in turn, while going for spectrally analyzing a target, so it used to give you the variations. So this is an example diagram that depicts how spectrally in each and every object that varies. Okay, so this is actually a region of overlap. So while going for the spectral reflectance given by a specific object like a tree or a vehicle, we used to only represent the average reflectance. So if you have gone through both the trees as well as your vehicles, is giving you the same radiance value here. So these are all the overlapping portions where your trees as well as your vehicles, it gives you the same informations. So if you have gone for the identifications with respect to the spectra, so automatically it gives you the variations very clearly. So that is within the 0.8 to 0.8 on, you will be having the variations. So that it is able to give you very clear identifications. So that's why these are all some of the advantages of hyperspectral images. So it gives you a very rich information and increases the capability of identifying the target, and it is more precise characterization and the determination is possible. So this is a way we use it to acquire the information on the hyperspectral images. So if you have seen, so these in turn it depicts the number of bands over which we are acquiring the informations. So this is a single spectral band and this is another spectral band. So this area over this spatial information can be observed on the hundreds of spectral bands. So that's the difference between your spectral class and the information class. Actually a spectral class may vary, but it may belong to the different images. So if you are having the different spectral value, in turn it gives you a different information. So this is the ideal case, but in the reality it won't be the case. Say for example, if you have taken any images or a plant or vegetations, it won't green, the leaves of your plants or your trees, it won't be green in all the time. So sometimes you will be having that as a green and sometimes you will be having that as a yellow, like that. So you used to have the different spectral informations. However, all those spectral informations, it will be belonging to the same class. Okay, so that is vegetation. However, the leaves of your vegetation is different. So in the reality, even though it gives you a different spectral informations, it will be belong to a same class. And similarly, you are having another thing, that the same spectral class can be assigned to the three different classes. So if you have gone for the classification within the plant itself, so at that time, depending upon the spectral nature, that can be classified to either first class or second class or third class, like that. So in the reality, either it may be different spectral classes, it will be allotted into the same information class, or a same spectral class, it will be allotted to the different information classes. So this is a general framework of your hyperspectral image classifications. So where you will be having this thing, that is if you are having the hyperspectral imagery that occurs in information over the 200 bands, the first thing you have to do is you have to reduce the dimensionality, and then it has to be given as a fraction of all the spectral information. That is the process of your unmixing, and then the classifier, it will be do the classifications to make your spectral classes into information classes. So as I say, this is a blessing of your increasing dimensionality. So that is the separation between the two different classes. It is very clear when you have gone for the higher spectra, and the curves I said the increased dimensionality. So if you are having a dimensionality which will be an increasing one, automatically the number of training samples required will also be a higher one in order to accurately classify that. So if you have gone for higher spectra, the training information available will be very less. So that you used to have a trade-off between it. So even though it gives you the very high information in terms of your spectral, the requirement of your training is also a matter. So that's the way we used to say that this is a curse of your hyperspectral images, and so the curse as well as your positive thing, both the cases, benefit is nothing but your increased spectral informations. Thank you.